All right, so here we're starting on page M244, so go ahead and get there if you're not there already. This is where we left off in class, so that's where we're picking up here. It says, let's determine how translations impact the graph of the linear function f of x equals x. So we're just starting with this basic function with a slope of 1, y-intercept of 0. It's the basic function for the linear family. And it's the simplest type, so that's what the basic function means, okay? So here's our worked example. It's saying we can translate the graph down 5 units by moving each point 5 units down. So if we started with this function that has a y-intercept of 0, and we translate it 5 units down, it's going to look like this graph here, the graph of m of x. So here is our original graph. That's what the table of values would look like. This is what our transform graph is going to look like. If you notice here, do you see how the x's stay the same? And what's happening when we shift down, when you think of shifting down, it's changing the y coordinates. So our y coordinates are going down 5. So we take this and it goes down 5 and all of the y values go down 5. Okay? So down here it says consider the translated function m of x. So we're looking at this one here or looking at this lower graph here. Identify the slope and y-intercept. So if you look, our slope is still 1. So let's go ahead and write that. And now our y-intercept is at -5. Then write the equation for the function in general form. So we're going to call it m of x equals, and when we're doing this, remember it's y equals mx plus b, and our m is our slope, so we'd have 1x, or just x, plus b would be plus -5 or -5. So that would be our function there. Okay, the one on the top of the next page is almost identical. So here, instead of going 5 units down, we're going to go 5 units up. So all of our x's are the same. And what's going to happen to the y's is we're going to add 5 to the back of all of these. So if we added 5, we would get 3 for this. If we added 5 here, we would get 4 for this, and so on. This one would be adding 5 would give us 6 and 7. And then if we go ahead and we graph those, I don't know if we need to graph it. Translate the graph, yeah. And it says label your graph P of x. So we want to go up 5, plot the point. And this one up 5 would be here. So I'm just taking those points that are on the graph here and we're shifting them up 5. And then you can go ahead and use a straight edge of some sort here to go through all of those points. And it says to label this, so we're going to go ahead and label this P of x. And then it says identify the slope and y-intercept. So again, our slope is 1, so slope equals 1, and our y-intercept is now up at 5. So if we plug into y equals mx plus b, it's just going to be 1x plus 5, or P of x equals x plus 5. All right, and then this one's asking about f of 2 and p of 2. So f of 2, that means this function at 2 is 2, and p of 2 means this function at 2, which would be 7. So that's what we're comparing down here. It says compare the values. How did the transformation affect the value of the function at 2? It just added 5 to that function, right? So let's write here that our f of 2 was 2 and our p of 2 was 7. That's what we circled up there. And it increased the value by 5. And if we read through this real quick, okay, it says for the basic function here, the transformed function y equals f of x plus d shows a vertical translation of the function. Okay, if D is greater than 0, that means it's going to shift up. But if our D value is less than 0, so if we were like subtracting 2, it would shift down that many. Okay, so when it's adding to the back here, it's going to be a vertical up or down. Up if positive, and it would be down if that's negative or if we're subtracting. That's what that whole paragraph there says. You're going to see that more as we move through Algebra 1, and you're also going to see it a lot when you get to Algebra 2. All right, so let's go to the next page here. Okay, it says consider the graph. So this is the graph of 2x minus 1. So the slope is 2, you can see that, and our y-intercept's -1. So they already graphed it. That's our j of x. Now it says translate the graph of j of x up 4 units. So if we go up 4 units, you're just picking some data points here, and you're going to go up 4, and you're going to put a new point there. So I'm going to grab this point here, and I'm going to go up 1, 2, 3, 4. And then this point, 1, 2, 3, 4. And do as many as you feel like you need here. 1, 2, 3, 4. I'm just going to kind of do the same ones that they did on the last page. Okay, so it says translate it up 4 units, label this Q of x. So let's go ahead and draw it in here and label it. Then write an equation for Q of x in terms of J of x. So we're using what we just learned on the last page here. We want Q of x in terms of J of x. So if we started with J of x here, what would we have to do to it to get to Q of x? And what we would have to do to shift it up 4 units is add 4 to the back of it. And that's going to make it go up that many. Okay, this one is really the exact same question. It says translated down 4 units. So if we did that, we're going to kind of skip it here. But if we did that, it would end up being down here. It would look parallel to these. It would just be down 4. So the only thing that's going to be different about this here is if we're trying to write r of x in terms of j of x, is we would take our j of x and we would subtract 4. And that would shift it down 4 units. And then it says rewrite Q of x and R of x in terms of x. So let's just do our Q of x that we were working on up here that we have the graph for. The two things that we really need when we're writing these equations are our slope and our y-intercept. So when we're looking at Q of x, I'm just going to write it up here. My slope, we're going up 2 over 1, up 2 over 1. So our slope is 2 over 1, or just 2. And then to find the y-intercept, that's where it crosses the y-axis, so that's at 3. So my equation, remember we're doing y equals mx plus b. So my m is my slope, so it'll be 2x plus 3. So I'm going to go ahead and write that down here. This is my Q of x equals 2x plus 3. Okay, and what do you notice? They're going to have the same slope. When we shift up or down, they'll have the same slope. Or parallel, you might say. That would be saying really the same thing. You could write them both. Okay. All right, on to activity 3.2. So activity 3.2 is going to be similar, but this is a little bit trickier here. So we're going to start with the same f of x function here, just x, our basic linear function. Suppose the outfits are changed by a factor of 4. So they're changed by a factor of 4, meaning we're going to multiply by 4. So what we're going to do, the x's here stay the same, and we're going to multiply by 4 for each of these. And that's what our new values are going to be. So if I multiply by 4, I get -8. then -4. 0 times 4 is still 0. 4 and 8. And then let's go ahead and plot that. And we're going to call this a of x. So after we're done plotting it, we're going to call it a of x. So my 0, 0 remains 0, 0. My -1 goes with -4. -2 is with -8. So I'm just graphing these points here. 1 goes with 4. And 2 goes with 8. And then we're going to get this so that it goes through all of those points. So grab a straight edge if you haven't yet. You can always pause the recording as you go grab that. Alright, so here is my a of x. So we've sketched it and completed the table. And then it says identify the slope and y-intercept and then write the equation. So when we're looking at this, our slope, we're going up now 1, 2, 3, 4 over 1. So my slope is 4 and it still hits the y-axis at 0. So my y-intercept, still 0. And then I write my equation, it's a of x. So I want to write a of x equals, and then our slope times x, and you could put plus 0 back there, but you don't have to put the plus 0. All right, on to the back here. This one's really similar, but a little bit harder because the numbers aren't as nice. So with this one, it's changed by a factor of 2/3. So then what we're doing is we're taking these times 2/3. And remember, you have a calculator, okay? So if you have trouble with multiplying this, you can multiply this in your calculator. How you would type it is you'd do -2 times parentheses 2 divided by 3. And if you have a decimal, that's okay for right now because the decimal is going to give you a spot to plot it. I'm going to write them as fractions, and I'll show you how to do this in your calculator so you can get the fractions too. It's just kind of nice to know. But if I multiply all these by 2/3, these are the numbers I'm getting here. And then we're going to plot those on the graph. While you start plotting those, I'm going to grab my calculator here. All right, and in my calculator, if I do -2 times parentheses 2/3, 2 divided by 3, and I hit enter, it gives me this decimal. If I want that as a fraction, there's this math button right here, and it's fraction, and it'll switch it to a fraction for you. So that's that -4/3 that I came up with real quick. So if you need to use that, sometimes it's we get more complex fractions coming up, so that sometimes helps people. Okay, now I want to plot these points. So you might have already started that. We've got our 0, 0. -1 is with -2/3, which would be like somewhere about there. -2 is with negative, that's like 1 1/3. And then this one's +2/3 and +1 1/3. So it looks something like that. So it's a little less steep than it started. But it looks like it's still going through that same spot for the y-intercept, so that's going to come up here in just a second. Okay, and let's label it correctly. So this one is my b of x. And my slope is a little trickier, but my y-intercept is still 0. And the slope is like our rise over run. We know we went up 2/3 to get over here to 1 because we got this point right here. So my slope is actually 2/3. And then if I write my equation, it should be b of x equals, and then you just take your slope times x. And if you want to put the +0 back there, you can. If you don't like it there, you can get rid of it. You could just have 2/3 x. All right. So moving over to number 3. This is, again, similar, but it's different because it's a factor of -4. So what is that negative going to do to the graph? And we're going to see it here. So if we multiply by -4, it's going to change from negative now to a positive. So this one's going to be 8. This one times -4 is going to give me 4. 0 stays at 0. 1 times -4 and 2 times -4. We can plot all of those then. And then we're going to draw our line through those, and we're going to make sure we label it here. So this is C of x. So when we look at that, it made it steeper, which we probably anticipated that happening because of the 4. That happened when we multiplied by 4 before it made it steeper. But the negative actually flips it. So instead of being positive up here, now it's negative down here. So it reflects it over this x-axis. And we'll be doing some of that work here in just a page here. So it's coming up. So our slope now, we're still going up 4/1 like we did in that previous problem, but we're going up and to the left, so it's a negative slope. So our slope is -4, just like what that factor is up here. And then our y-intercept still hits here at 0. All right, then we want to make sure we can write our equation. So we should be getting good at writing these equations here. This one's C of x equals, and then it's just -4x plus 0 if you want it there. Okay, and then what this is saying is if we're multiplying the front by something here, what it's going to do is a vertical dilation, okay? So if my a value or absolute value of a is greater than 1, like 4 or 5 or 2 even, what's going to happen is it's going to vertically stretch it. And if it's between 0 and 1, so if it's like a fraction or a decimal, it's between 0 and 1, so like a half or a third, what's going to happen, it's going to vertically compress it by that factor. And this stuff's coming up on the next page, okay? So if we compare our values here, f of -1 and c of -1. So if I go back up here, f of -1 is here, and c at -1 is here. So let's write those down. F of -1 equals -1, and c of -1 was 4. What happened? It just multiplied by -4, which is how we found it. So that's all we got to write here. Multiply by -4. All right, the next page here. We need to make sure that we can find where this is on our Google Classroom, so we'll talk about that here. But we're going to go ahead and we're going to work on these. I'm going to go through several of them. And these are also on your Google Classroom. So if we go to our Google Classroom, it should be the very top thing in your classwork. It says, this is our Module 2, Topic 1, Lesson 3, Dilation and Translation Practice. So if you click on that, there should be this edge elastic thing here that you can take. This will help you a lot with practicing what's going to be on your test here coming up. Okay, so make sure you go to that and you're going to fill these in, but first fill them in your book. Okay, so we're going to go through at least half of these together. If I do A, I think you can do B. So we're going to do A, and then you're going to go ahead and try B. I would probably pause it and do B before you move on to the next part. Okay, so here it says, let's consider more transformations of the basic function f of x equals x. Describe the transformations performed on f of x to produce g of x. Then graph g of x. Write the function equation in general form. Okay, so some of the things that I see here, I see this 2 that's multiplied in the front. So what this does is it's going to vertically stretch it by a factor of 2. So that's what I'm going to write here. The 2 is a vertical stretch by a factor of 2. And then this plus 7 in the back, that's going to shift it up 7. So when you look over here, same idea. Okay, the 3 is like what this 2 is. And the minus 1, if this one goes up 7, this one's going to be going down 1. Okay, so you should be able to get that part of it. And then what I'm going to do is I'm going to try to come up with some points here. So let's go with f of x, and then what is g of x going to be? And I'm just going to kind of put like x comma y at the top here, and I'll show you why in a second. But what we're doing is we're doing a vertical stretch of 2. So if we're vertically stretching 2, what that means is you look at the height. So like here at x equals 2, the height is 2. And if we vertically stretch it, we're trying to stretch it taller by a factor of 2. That means the height's going to double. So instead of being a height of 2 here, it's going to end up being a height of 4 there. But then don't forget about this guy. We also have to go up 7. So with both of those, that's going to change the y coordinate. Nothing's going to happen to my x coordinate of 2. Okay, if I vertically stretch it, it's making it taller, which affects the y value. And if I shift it up 7 from there, that's going to change the y value also. So when I'm looking at what's happening to my x and y, my x doesn't change at all. My y gets doubled, and then I have to add 7 to it. So if I take these coordinates 0, 0, the 0 for the x stays the same. The x always stays the same. And then what's happening to the y here is we're doubling it, which is still 0, and then I'm adding 7. So 0, 7 is where that point's going to be. And then I'm going to grab a couple other points. So let's grab 1, 1. So you can see 1, 1 on this graph. What's going to happen to it? The x stays the same. The y value, I'm going to take it times 2, and then I'm going to add 7. So 2 times 1 plus 7 gives me 9. And then we could take 2, 2, but I think that one's going to end up off the graph. So I'm going to try -1, -1, because that's on the graph of the original here. The x stays the same. All right, here, be careful because it's a negative. So we're taking 2 times -1, which is -2, and adding 7, so we get 5. And then I'm going to plot these points. So these are the 3 points that I'm going to plot now. 0, 7, 1, 9, and -1 is at 5. And I always pick 3 points because then if I mess one of them up, I'll see it. Because what I should get now, I should get a line. If it's not a line, if those 3 points aren't in a line, we did something wrong with one of the coordinates. And then you know you messed something up and you gotta try it again. Okay, so here is my new graph. And this graph is g of x, so I'm going to call it g of x here. And then the other thing it says, so describe, we described it. That's the vertical stretch and up 7. Then graph, we graphed it. And then write the function equation in general form. So then if I'm writing the equation, I write g of x equals, so first I want to find my slope. I'm going up 2 over 1. So it's going to be 2 times x. Plus my y-intercept here is at 7, so plus 7. That would be my last bit for that problem. So if I'm trying to do that on edge elastic here, go to your edge elastic, and we're going to fill in what we just did. Okay, so the function is, it was vertically stretched by a factor of 2, and then it was translated up by 7 units. And if you're trying to type and it doesn't type, you can just use the keypad. Sometimes I find that I run into that. And then here we use 0, 0, 1, 1 and -1, -1, but we'll have to do this point to fill it in here. So here I just want to know what the g of x value is, which is what the y value is. Okay, the x is still going to be 0. So if I plug 0 in for my y, I got 7. When I plugged 1 in, I got 9. And here's where it's not letting me type, so I just click. And then if I plug 2 in, I would get 4 plus 7, which would be 11. And then when you try to graph it here, I click this first. I don't know if I need to, but I have every time. And now I'm going to graph the point 0, 7, 1, 9, and 2, 11. So I want to make sure it goes through all those. So I'm going to start with 0, 7, and 1, 9, and I want to make sure it goes through those. So 0, 7. And if I click, it automatically goes. And then if I drag this one, I've got 0, 7, 1, 9. And then if you look, 2, 11 should land on there, which it does. And then write the equation in general form. So our equation that we came up with then was 2x plus 7. So you're typing that in. And then you can go to the next one. And this one I'm going to leave up to you to do. So what I would do right now is I would pause this and I would try number 2. Okay, do it in your book and then do it in Edge Elastic. Then I'm going to go ahead and I'm going to move on to C or D. Maybe I'll do, yeah, I think I'll do C. And then I'll leave D up to you guys. So looking at C here, we've got a couple things going on. Okay, we got this 1/3 out front. So again, that's going to be a vertical dilation. And this is going to compress it because it's 1/3. It's smaller than 1. So this is a vertical compression. So let me just do this. Vertical compression. And the factor there is 1/3. So it's going to be 1/3 as tall as it was before. And this +2 does the same thing as it did before with the +7. This one's +2, so it's up 2. So same idea over here for your description. And then we want to come up with a table here. So I've got my f of x and my g of x. And we know that the x-coordinate, nothing's going to happen to it with these. So I'm going to start with my xy because I like doing that. And we're going to figure out what happens to the y. And then I'm going to pick some nice values here because this one's a little bit harder with the 1/3. So if I'm doing something that's 1/3 as tall and I'm over here at 3, 1/3 of 3 is just 1. So I want to use this point here. I'm going to end up using 0, 0. And then I'm going to use 3, 3. And then I could either use 6, 6, because that would work pretty nice, or -3, -3. And I'm going to work a little bit smarter here than working too hard on it. And I'm going to look here for question 3. It looks like they use -3, -3. So I'm going to use that. So when I do my edge elastic piece, it matches up. So let's go ahead and do -3, -3. Okay, so what's happening here? Vertical compression of 1/3. It's 1/3 of what the y value used to be. So if the y value is 3, it's 1/3 of that. So I want 1/3 times the y value. And then up 2 means I'm going to add 2 to the back of it. So 0, 0. Remember the x's stay the same. So I'm just going to fill those in here. And what's happening to the y's is we times them by 1/3 and then we add 2. So if I take 0 times 1/3, it's still 0 plus 2. 3 times 1/3 is just 1 plus 2. And -3 times 1/3, again, if you need to use your calculator, you can, but -3 times 1/3 would be -1 plus 2 would just give you 1. And I want to plot these and make sure they end up in a line. So 0, 2, 3, 3. Oops, there we go. And -3, 1. And those look like they're collinear, like they form a line there. Let's check by using a straight edge here. That looks good. I'm going to label it g of x, so that's what it's telling me right here. And then I want to write my new equation, so let's not forget that part. So we want to figure out our slope. Rise over run. 1 over 3. And then y-intercepts here at 2, so plus 2. So that would be my equation. And that should be pretty easy to put into edge elastic then, okay? But then I would go ahead and pause, and I would put this in edge elastic, and then go ahead and get D. Do it in your book first, and then go ahead and do that in edge elastic also. Then E and F are a little bit different again. And I think E is a little bit easier than F. So I'm going to go ahead and do F with you. And then you're going to go ahead and try to do E and submit it in edge elastic there. All right, so looking at part F, there's 3 things happening now. This negative in the front does the reflection. It reflects it over the x. So I'm going to write that, reflect over x axis. The 2/3 that we see here, that's going to be a vertical compression. By a factor of 2/3. 2/3 is smaller than 1. And then this plus 5 is up 5. And so then we want to think about how that's going to change my table here. And the nice thing, I think, is it's just switching the y's right now. We will end up switching the x's later on when we get a little further into some of this stuff. But for right now, we're only switching the y's. So my x is going to stay as is. And then we got to think about what's happening to the y's. So if it reflects it over the axis, it's going to make it, instead of like positive, it'd make it negative. Or if it's negative, it would switch the sign to positive. So it's going to make it the opposite of what it was. And then the 2/3 is going to get multiplied by the y. And then up 5 is going to add 5 to the back of it. So in the back here, we're taking the negative 2/3. The negative will change its sign. And the 2/3 will do the vertical compression on it, times y, and then the plus 5 just goes in the back here. And then I'm going to pick the points that are on edge elastic, and I'll go ahead and plot this one with you guys on edge elastic. So if I go to, I think it would be this one. Yep. Okay, so describe the transformations performed. So the function is reflected over the x-axis. It's vertically compressed by a factor of, where's my fraction? 2/3. Maybe just this one. There we go. Okay, so 2/3. And it's translated up by 5. Okay, so that would be the first part there. Then for part B, I want to use these 3 points. So those are the points I'm going to use in my book. -3, -3, 0, 0, and 3, 3. So let's go ahead and do those here. -3, -3. 0, 0, 3, 3. So my x's stay as is. And my y, it's getting multiplied by negative 2/3. So if I take negative 2/3 times negative 3, it's going to turn to positive 2. Plus 5 would give me 7. And then this would be 5. And plugging 3 in, negative 2/3 times 3, the 3's cancel, so we get negative 2 plus 5, which would be 3. And then I'm going to plot them because it'd be easy to mess these up. So I'm going negative 3 with 7. And then I'm going 0 with 5. And then 3 with 3. And those look collinear. It looks like they're all in a line, which is good news, because if they weren't, we messed one of them up. There we go. We extend it on in both directions here. Put arrows on the end, we call it g of x, and we got it. And then we want to write our equation. So our equation is g of x equals, and our slope up to over 3, but you can see it's negative. It's going up and to the left, so it'd be negative 2/3 x, and then plus 5 because it hits the y-axis at 5. So now we have all the pieces here to fill into our edge elastic. So now you should be able to fill in these coordinates here. So this is just the g coordinate that went with negative 3, which was 7. So we got 7, 5, 3 here. And then we're trying to graph it. So 0, 5, and 3, 3 are the couple that I'm going to look at here. 0, 5, and then this one I want to have at 3, 3. And then if I write my equation here, it was negative 2/3 x plus 5. So this is the fraction button there. All right, and then hopefully you're checking answers as you go through that edge elastic piece. So now we want to finish with the bottom part of this. Okay, this is stuff that we've already talked about, and then you're going to do the last piece in the edge elastic part there, which is the talk after we're done with this. So this here, how does changing the a value affect the slope of the function? So if it's greater than 1, and why we're saying absolute value is because if it's negative, what's happening is it reflects it. So we're kind of ignoring the negative and just treating that part as a reflection. So let's put this first. If it's negative, it's going to reflect over the x-axis. But if it's a big a value, like a 4, then that changes the slope to 4. So what's happening to the slope is it's increasing. So it'd be becoming steeper there. And if it's between 0 and 1, then it decreases. Okay, and if we look at what's happening in the back here, if it's a positive, what's going to happen is it's going to go up, right? It's going to shift it up. So if D is positive, it's shifted up. Shifts, there we go. And if D is negative, it's down. All right, so we're skipping a couple pages here. So this page here, skipping. And this page here, skip. So the talk, it's here, but it's in edge elastic. So if you want to write it in here, that's great, but where it needs to get done at is in edge elastic. So that's this one right here. Question 7 of 7. You're trying to figure out which one's which based off of what we just did. Okay, what would the plus 8 do to the original? And the original is this one right here. All right, so once you're done with it, you can check answers, you can submit it, but that needs to get submitted today. Then the last little thing here that we're going to look at is page 61. So page 61 in your book, it should look just like this, comparing tables and graphs. It says large recycling centers pay out different amounts per ton of cardboard. Washington County Recycling Center is over here, and it's listing the amounts in a table. And then Jackson County Recycling is using this graph to explain it, okay? So they're paying out different amounts here. Each representation shows a functional relationship between quantities. So it's just saying they're both functions. Label the quantities and their units in the table and on the graph. So what this would represent here would be the weight of the cardboard. And that's what would be then across the bottom here. These aren't like the same as each other, okay? This is for a different set of values than this is, but this would still be our weight of the cardboard. And then up the side would be like how much you're making on it. So let's call that the payout amount. How much they would pay you for that much. And same thing up the side here. All right, so for number 2, we're trying to figure out if it's greater than, less than, or equal to. So when we compare these two values, I'm going to write what I see in my table and in my graph. So W of 0.5. If I look at W at 0.5, it's 750. So this side here is 750. And if I look at the Jackson County one at 0.5, 0.5 looks like it's 10. So that inequality would go this way. Okay, same idea, but now we're at 1, so this one would be 15. And this one at 1, follow it up, and it looks like it's at 20. So Jackson would still be more there. Okay, and then at 3, this one takes a little bit more work because we don't have it right here. But if we look, if we're going from 1 to 2, we can see here that the slope is 15. And you could do slope like we did earlier on, where we do our change in y over our change in x. And we would see that our slope is 15. So it's going up by 15 each time. So if we got to 3, it would be at 45. So this would be 45. And then if we're looking at j of 3, we can see our slope. If we want to look at our slope, we want to make sure we're going over 1. So you got to go up 20 before you go over 1. So our slope here would be 20, and it's starting at 0. So if we started at 0, it starts at 0. At 1, it's at 20. And it keeps going up by 20. This would be 40, and this would be 60. So this one's 60. So I would probably take my recycling to the Jackson County Recycling. You're going to make more money. Okay, compare the y-intercepts. So our y-intercept here is definitely 0. And to get to the y-intercept here, if we're going ahead 0.5 each time, it's going up by 750. So if we want to go back 1 spot so I can get to the y-intercept, because the y-intercept's when x is 0, it's also going to be 0. So it says compare the y-intercepts of each relationship. So I'm going to put that the y-intercepts are both 0. what does each mean in terms of the relationship? If you think about this, that makes sense. Our y-intercept should be 0. If we don't take any cardboard in, we're not going to make any money on our cardboard, right? So 0 tons of cardboard. Oops, cardboard pays out $0. And that says, which recycling center would you choose? So we're going to go ahead and say Jackson County. And provide evidence. They're paying $20 per ton. Where when we looked at Washington County, it was only 15. So this is the one that we would choose, just to make it clear, okay? All right, and that's all we're gonna do for lesson 4. So what we have right now, we've got our book work done. You need to make sure that you finish and submit this edge elastic. Okay, you can check answers, hit submit when you're done. And then we've got Mathia. So you should be 10 workspaces into your Mathia. If you're not, then on Friday, we'll be working together during flex time is the plan, okay? So make sure that you're getting your Mathia done. If you're not there yet, keep working on it throughout the week here, and then you will have a test on Monday of next week. So Monday falls on the 23rd there. That's your test day, okay? So email me if you have any questions, and we'll see you all later.